An aggregation class works similarly to the list of objects that we worked on last time, where we were taking objects and instead of instantiating them as individual variables, we're instantiating those objects as a list. This takes it one step further and actually creates an object that we use that contains that list as one of its properties. In addition to that list as a property, it also contains methods that are related to the management of that list. So an aggregation class, for example, would be like a library class that aggregated book objects. Okay, so we have all these books. We could store them in a list, but all a list does is store things. If we wanted to manage that list, there's no functionality associated with that list that allows us to manage those books in that library, like adding books or changing titles or checking them out, checking them in, whatever functions you want to have a library be able to do with the books. A list can't do that. So we create an aggregation class to represent the library and all of the functionality of the library. So a library has the books, but it also adds books. It periodically removes books. It may check them in or check them out and that sort of thing. So if we want to look at that, and this code is, all of this code is posted in Canvas for you. So you can grab it later and play with it and look at it and mess around with it, because that's a great way to learn this stuff when it's a little bit more abstract like this. But let's say we have a book class, and I'm going to go through this code sort of line by line so that you have a good idea of what's going on here. Rather than write it, I thought I would take the time to just explain what's going on. So we have a book class, and that book has initialization method, right? The underscore, two underscores, INIT, an initialization method that gets called when you create an instance of that object. We supply it with a title and an author. Okay, title and author go into the variables or the properties of that object. And here's a new special method that I want to share with you. The two underscore str allows you to set a string as a description of that object, so that if you print, like if I have a book called my book, like an instance of book called my book, and I set the string to the title and the author, title by author, then when I print, if I print my book, it will actually print this, which can be very handy. So this is the ability to set a string that represents a description of that object. If you don't want to go with the default, which would be class book, that's the description that you would get if you printed a my book instance of book by default. So you can change that default to be something more useful and meaningful, which is kind of a nice thing. So we've got our book class, title, author, and the description. Those are the properties there. So if I want to create an aggregation class called library, a library contains books, but it also does other things, right? So when this initializes, it is going to set an empty list. Now, this is where it connects with what we did last time in storing objects in a list, because the mechanism for storing that collection of objects is just a list inside the class library. So it's a property of library. Okay, so we've got a method called addBook, and notice that it takes a book as an argument. So it's an object now. that it's taking. So it goes self, books, append, right? We're going self, setting the context. Books refers to that property, and append, we're adding something to that list. And what we're adding is that book. We're feeding it an object called book that gets appended. Piece of cake. And I could say here, you added a book to the library or something like that if I wanted to give feedback to the user when that was going on. Remove book, again, takes an argument of book. And what it's going to look for is it's going to look for that book. If book is in self books, if that object exists in that list, then you remove it. Okay, so we're using the remove method of the list data type to remove that book. And if it's not in there, it says that book is not in the library. Here's a list books method. This is a library method, not a book method. It's important to remember, a book can't add a book, only a library can do that. A book can't remove a book. A book can't remove itself. The library controls the books. The library removes the books. A book can't list books, can't list itself as part of a group. The aggregate class does that. So the library lists the books. And here's a new function that we haven't talked about, but it's a handy function. It will take any list or collection and it will go through them one by one and assign them in pairs an index or a number. And you can start, you can see it takes an optional argument of start. If you leave that off, it starts at 0. So it'll just give you the index of them in that collection. But when I say for I, comma, book in enumerate self.books, starting with 1, for each one of those, it presents a data pair, an index and the object. So it's going to be index, object. And anytime you see book in an F string like that, remember, that's why we defined this, because now anytime we print that object, that's the description that's going to get substituted in there. So this is going to print the index and the title by author. So that's the library construction there. And now we get into the main code program, or the main program area, where we have the menu. This should be very familiar to you by now. Okay, so we have an if branch here. So if choice equals 1, if we want to add a book, we enter the book title, we enter the author, and then new book equals book title author, and then we create the new book using that object, the book object, and then we use the library dot add book, and then we feed it the new book we just created, and then we print that the new book has been added to the library. If choice equals 2, we're going to remove a book. So we're going to invoke the library.list books, which runs that enumerate command on them. Book index equals, enter the number of the book you want to remove, and it has an int and then a -1 over here. So that's how we get from a 1, 2, 3 to a 0, 1, 2 to correspond to the index. And here's a if statement structure that we haven't played around with really, but this is something you can do. This is the same thing as saying if book index, which is supplied by the user, if book index is greater than or equal to 0, so if 0 is less than or equal to book index, and book index is also less than or equal to length of that collection, library.books, right? Then what we have here is, it's the same thing as saying both of those as separate, like an and. If this is true and this is true, but it allows us to put something in a range if it's between this and this, basically. So that's an easier way. It's a shorthand way of saying that. But then that checks to make sure that whatever number the user enters is actually in the library books collection. So now it takes that index and it uses that to grab the book from the library collection of books, using the index, puts it in removed book, and then it removes library remove book using the library's remove book method, giving it the book that you're supposed to remove, and then it says the book has been removed. And if the index isn't within that range, it gives it a invalid book number. And then the last two choices are just list the books or exit the program. So this one says library.listbooks, and this one just breaks out of the loop, and then we catch everything else as an invalid choice. So this program is a handy little program. So we want to add a book. Okay, so if I want to list books, now I have Old River by Bill Moseley. So if I list the books again, now I have this. Now I don't have a mechanism in here to change a book title, which would be a little bit more complicated. I would have to actually do something to create a method in the books class that allowed me to change that title, because that property is part of the book. And then I might even put a wrapper method inside the library. Wrapper not as in like Tupac, but as in like a candy wrapper, right? So wrapper is just a method that invokes that the subclass method. But if I want to change that, I have to delete it and re-add it. So let's remove a book, and then I put in the second one, and then if I list the books again, that one's gone. So that is a class-driven library using a base class of book, right, and a aggregate class of library, which actually creates and stores a collection of books as a property in the library. So what I want you to do before you jump into the assignment is I'd love for you to actually take this code, open it up in PyCharm, and play around with it. Do some things to it so you kind of get your mind around that code. Before that, I want to make sure that you understand